We are starting a new activity. So we're in activity 15, page 227. We're going to compare equations. So lesson 15.1 is all about writing equations from graphs and tables. So we're going to look at writing a linear equation if given a graph or a table, and then analyze key features of a function given its graph. So Travis Smith and his brother Roy are co-workers of a trucking company. One of their regular weekly jobs is to transport fruit grown in Pecos, Texas, to a Dallas, Texas distributing plant. Travis knows that his customers are concerned about the speed with which the brothers can deliver the produce because fruit will spoil after a certain length of time. So we're going from Pecos to Dallas. Pecos to Dallas. Before, when I was teaching, this lesson didn't mean anything to me, but now I went to Dallas last summer, or to Texas last summer for the first time, so this it's a little bit more interesting. So let's look at this map. Can we find Pecos and Dallas? Here's Pecos. Here's Dallas. I flew into Dallas. I went to Fort Worth. So obviously, if they're driving from Pecos to Dallas and they're delivering produce or fruit, they want to take a straight shot. Right? They're probably going to go from here to there. Hopefully, if there's highways or freeways, they're not going to drive all the way down here and then back up and around to get to Dallas. That's going to take too long. Okay? So Travis wants to address his customers' concerns with facts and figures. He knows that a typical trip takes 7.5 hours. He makes the following graph below. What I want you to do is analyze or look at the graph, observe the graph, look at the numbers, look at the labels, and write down everything that you observe or that you recognize under question A. What information does the graph provide? What information does the graph provide? So I noticed that my y-intercept is 0 and 450. So 0 hours, the time since leaving Pecos. 450 miles is the distance from Dallas. And my x-intercept is 7.5, which stands for the hours or the time since leaving Pecos. So based on these intercepts, I know that Pecos is 450 miles from Dallas. And the graph also tells me that it takes 7.5 hours to drive from Pecos to Dallas. What else do we notice? We notice that our line is decreasing. It's going down. So we have a negative slope. Well, this makes sense because as Travis is driving, he's getting closer to Dallas. So the distance from Dallas is decreasing, while the time since leaving Pecos is increasing. So we have a negative slope because we're getting closer and closer to our final destination. All right, letter B. Locate the point with the coordinates 3 to 70 on the graph. Label it point A and describe the information that these coordinates provide. So we're going to go over to 3, up to 270, label it with an A, and what does that stand for? Well, we have to read our labels. So 3 comes first, and that's on our x-axis, or here it's labeled H for hours. So what that means is after 3 hours of travel, after 3 hours of travel, Travis is, let's look at what the y-axis is labeled, or the d-axis for distance in miles. So that means that is the distance from Dallas. So Travis is 270 miles from Dallas. Or he has 270 miles left to go, left to travel, till he reaches his final destination. Question C. According to the graph, how many hours will it take Travis to reach Dallas from Pecos? Well, we've talked about this. 7.5 hours. How do we know? Because this is our x-intercept. Right? If we look at our graph, it's this x-intercept point right there. When Travis's distance from Dallas is 0 miles, he has driven a total of 7.5 hours. Question D. Interstate 20 is the direct route between Pecos and Dallas. Based upon his graph, at what average speed does Travis expect to travel? And explain how you determined your answer. So please pause the video, and I want you to think, how many miles is he traveling? And how many hours does it take him? And you're going to divide those two numbers. Okay, divide those two numbers. You can do it. So he's driving a total of 450 miles from Dallas to Pecos, Pecos to Dallas. And remember, it took him a total of 7.5 hours. So if we divide these two things, go ahead and do that. We get 60 miles per hour. So that is his average speed. 60 miles per hour. 450 divided by 7.5. Question 2. Complete the table to show Travis's distance from Dallas at each hour. Okay, so hours, since leaving Pecos is your first column and it's filled in for us. In the time since leaving Dallas, or the distance, sorry, from Dallas. So if our hours are 0, he's still at Pecos. What's the total distance he has to drive? 450. Okay. Well, he's driving how fast? 60 miles per hour. So in 1 hour, he's driven 60 miles. So we're going to subtract 60 because we're 60 miles closer. So 450 minus 60, we're down to 390. Then in another hour, he's driven another 60 miles, so we're 60 miles closer, so we're going to subtract 60 again. So we're at 330. He's driven another hour here, so that means we've gone another 60 miles. So now we're at 270. Subtract 60 again, keep going, you can do it. 150, 90, and 30. So our table doesn't end at 0, remember, because it takes 7.5 hours. So at 7 hours, he still has 30 miles left to travel. Okay? So for question 3, it says use your table to adjust it above, or we could also use the graph, whatever you prefer, to write an equation that expresses Travis's distance d from Dallas as a function of the number of hours since he left Pecos. Now, the easiest way to write the equation is in slope-intercept form. Y equals mx plus b. Okay, but they want us to use d and h. So this would be d equals mh plus b. So we need to think, what is our slope here? What's our rate of change? And what is our starting point, our starting number? Okay, so d equals, now, how fast are we traveling? What's our rate of change here? We're driving 60 miles per hour, right? And that's a positive speed. But if I look at my table, my numbers are decreasing. They're going down by 60. If I look at my graph, we have a negative slope here. So our slope needs to be a negative 60 because our distance is decreasing. We don't drive at a negative miles per hour or a negative speed. We don't talk about the speed limit being negative. But because our distance from Dallas is decreasing, our slope has to be negative here. Plus, what's our starting point, our starting distance, our starting number of miles? It's 450. The graph of an equation in two variables is the set of all solutions of the equation plotted in a coordinate plane. The graph appears to pass through the point 690. 6 is h, hours. 90 is d, distance, or miles. We're going to use the equation to verify that this is true. What equation? The one that we just wrote above in question 3. So d equals negative 68 plus 450. Instead of having a h here, let's plug in this 6 and see if we get 90 as our answer. If we do, we're correct. So d equals negative 60 times 6 plus 450. So type this into your calculator as one big problem without the d. Okay, or you might be able to do this in your head, sorry. Negative 60 times 6 plus 450. This is negative 36, add a 0, plus 450. And in fact, we get 90. So yes, when we plugged in a 6, we got 90. So we know that after 6 hours of travel, he still has 90 miles left to go. And if we look above at our table, 690 is on the table. If we look at our graph, 690 is a point in our graph. We're going to do this 4 more times at the top of the next page. Generate 4 more ordered pair solutions to your equation by substituting 1, 5, 8, and 10 in for h. Does each point appear on the graph showing Travis's distance from Dallas? So what you're going to do is you're going to take negative 60 times 1 plus 450. and get your answer. And then you're going to do the same thing for 5. Get your answer. 8 and 10. Go ahead and start working. Use your calculator to help you if you need it. So when I plugged in 1, my answer is 390. 5, 150. 8 and negative 30. 10 and negative 150. So if we go back to the graph right here, if I go over to 1, up to 390-ish, yeah, I guess it's on our graph. Over to 5, up to 150-ish. Over to 8, down to negative 30, not on my graph. Over to 10, down to negative 50, not on my graph. Let's look at the table just to double check. If I'm looking, I have 1 and 390 right here. That was the ordered pair that we got. And 5, 150 right here. I do not see 8, negative 30, and 10, negative 150. So to answer question B, does each point appear on the graph? The answer here is no. The 2 points with a negative distance value or negative output do not appear on the graph because we cannot have a negative distance. We cannot have negative miles left to travel. So which of the solution points that we generated makes sense? That would be 1, 390, and 5, 150. Explain why only some solution points make sense in this context. Well, negative values don't make sense here because we're dealing with a real-life story problem, real-life scenario. Talking about hours and miles or distance. Okay, use what you know about the solution points in the graph to state the domain and range for the function. Ooh, domain and range. So remember, hopefully from first try, domain is the x values, or in this case it's our h values. When we're looking at domain, we look from left to right, horizontally. Okay, so where does my graph start? Well, it starts right here at 0, and it goes all the way, it stops right there at 7.5. Okay, so remember when we're writing domain and range, we use fancy brackets. You start at 0, and then you need less than or equal to hours is less than or equal to 7.5, and I end with a fancy bracket. So my hours, my driving time is between 0 and 7.5 hours. So for our range, we also use fancy brackets. It's called set notation is how we write it. And for our range, we're looking at our y-axis, or in this case, we use a d for distance, for miles. And we're looking up and down vertically from low to high, from bottom to top. So we start right here at 0, and we go all the way up to 4, woo, got crooked on me. We go all the way up to 450. Okay, I don't know why that did that. We stop at a 450. So 0 is less than or equal to 450. So our distance is greater than 0, but less than 450. So either we're at Dallas or we have 450 miles left to go. Use the graph to identify the 0 of the function. The 0 of the function, that just means your x-intercept. Okay, your x-intercept, which we've already talked about this. Your x-intercept is 7.5, 7.5. Where your graph ends along your x-axis.